On July 18, 1944, southeast of Caen in Normandy, the ground is shaking beneath one of the most powerful armored vehicles Germany has ever sent into battle. Dust hangs over the lanes and fields. Aircraft have just passed overhead, leaving the landscape scarred by explosions. Somewhere among the hedgerows, a machine weighing almost 70 tons is trying to maneuver through terrain never designed for something so enormous. Its long 8.8-centimeter gun points towards the Allied positions, while beneath the armor a 700-horsepower engine strains to move nearly 70 tons of steel. This is the Tiger II, Germany's newest heavy tank, and its arrival has created enormous expectations. Yet the machine has a problem that will follow it throughout the war. It is immensely powerful, but its weight is pushing its mechanical system towards the limit. And behind the legend that Adolf Hitler personally delayed the tank because it supposedly failed a reversing test lies a more complicated truth. The real story is not about one failed maneuver. It is about a weapon that entered production before its engineers had fully solved the consequences of making it so heavy. The Tiger II was born from a problem Germany could not ignore. By 1942 and 1943, the battlefield had changed dramatically. Soviet tanks such as the T-34 and KV series had demonstrated the value of sloped armor, while increasingly powerful Allied and Soviet anti-tank weapons were making older German designs more vulnerable. The Tiger I remained formidable, but German planners wanted greater protection and a more powerful weapon. The answer was a new heavy tank combining the Tiger's armor with the sloped protection already demonstrated by the Panther. The result was enormous. The Tiger II carried up to 180 millimeters of armor on the front of its production turret and mounted the 8.8-centimeter KWK 43L/71, a gun capable of engaging enemy armor at considerable distances. But protection and firepower came at a price. The tank weighed roughly 69 to 70 tons, while its 700-horsepower Maybach HL230 engine was already being used in the much lighter Panther and Tiger I. The transmission and steering system, therefore, had to cope with extraordinary loads. The Maybach OLVAR gearbox provided 8 forward and 4 reverse gears, but the problem was not simply how many gears the tank possessed. It was whether the entire drivetrain could survive the forces generated by moving such a heavy machine across broken ground. Henschel developed the production chassis, while Krupp was responsible for the turret. Porsche had also been involved in the competing development program, but the Henschel design ultimately became the production vehicle. The early Tiger IIs used a turret design with a rounded front, while the later production turret adopted a simpler flat front and thicker armor. Beneath the armor, however, the engineering challenge remained. The suspension used large overlapping road wheels and transverse torsion bars. The drivetrain incorporated a double-radius steering system. Every component had to cope with a vehicle substantially heavier than the original Tiger I. This is where the story of the supposed reversing failure becomes important. There is no surviving evidence establishing that Hitler ordered a production delay specifically because a Tiger II failed to reverse during a demonstration. Records instead show a vehicle program suffering from testing, manufacturing, and reliability problems, while Germany was simultaneously demanding that the tank reach the battlefield quickly. In fact, the Tiger II did not simply sit waiting for Hitler to approve it after one embarrassing test. Production began while technical problems were still being discovered. That decision would have consequences. The first completed Tiger II prototypes appeared in late 1943, and the vehicle entered production at Henschel's factory in Kassel. The first operational examples were rushed towards units preparing for the fighting in Normandy. The 503rd Heavy Panzer Battalion received Tiger IIs and brought them into combat during the Allied offensive around Caen in July 1944. The tank's first battlefield appearance was therefore not the triumphant debut of a perfectly finished machine. It was the beginning of an exhausting struggle between engineering ambition and mechanical reality. And the battlefield exposed problems that testing had already warned about. Early Tiger IIs suffered from failures involving the final drives, steering system, tracks, seals, and other components. The immense weight placed extraordinary stress on the drivetrain. Simplifications made during production could also create new weaknesses. One particularly important issue involved the relationship between the track and drive sprocket. According to a later briefing by Inspector General of Panzer Troops Wolfgang Thomale, production changes meant that only every second sprocket tooth engaged the track, producing sudden impacts that the final drive struggled to withstand. Henschel chief designer Erwin Aders later attributed the failures to the fact that the Tiger II had entered series production without properly incorporating the available test results. If you're enjoying this journey through history, subscribing genuinely helps us continue bringing remarkable true stories like this to the channel. In Normandy, the consequences were immediate. During Operation Goodwood on July 18, 1944, Tiger IIs of the 503rd Heavy Panzer Battalion entered battle around the Caen area. Allied aircraft, artillery, and armored forces were operating on a massive scale. The Tiger II's armor and gun made it a dangerous opponent, but its sheer size created another vulnerability. When mechanical failure struck, recovering the vehicle was extremely difficult. One company commander's Tiger II became irrecoverably trapped after falling into a bomb crater. Other vehicles were lost through combat, mechanical failure, or later abandonment as German forces retreated. The machine could be terrifying when functioning, but a disabled 70-ton tank was an enormous burden for an army increasingly short of fuel, recovery equipment, and spare parts. The comparison with Allied and Soviet tanks reveals the central contradiction. The American Sherman was dramatically lighter and mechanically simpler, allowing it to be produced and maintained on a completely different scale. The Soviet T-3485 was also far lighter, while Soviet industry was producing thousands of tanks and could replace battlefield losses at a rate Germany could not match. The Tiger II, by contrast, concentrated enormous resources into each individual vehicle. Its armor was exceptionally thick, and its 8.8-centimeter gun was one of the most formidable tank weapons of the war. But tactical power was only one part of armored warfare. Mobility, reliability, fuel consumption, maintenance, recovery, and production all mattered. The numbers reveal the imbalance. Only about 492 Tiger IIs were completed during the war, although the exact total varies slightly according to how prototypes and partially completed vehicles are counted. The Tank Museum records 489 produced at Henschel between January 1944 and March 1945, while other commonly cited production records give 492. Either way, the figure was tiny compared with German medium tank production and microscopic beside Soviet and American output. And the delays surrounding the Tiger II were therefore not the result of a single failed reverse maneuver. They were the product of a much larger problem. Germany wanted an extraordinarily powerful tank, but the industrial and logistical system required to build, test, maintain, and fuel such a machine was increasingly under pressure. Allied bombing made matters worse. Between September and October 1944, repeated raids heavily damaged the Henschel plant at Kassel, with some estimates suggesting that around 95% of its floor area was destroyed. Production continued, but at sharply reduced capacity. The irony is that the Tiger II's greatest weakness was not that it lacked power. It had too much ambition built into one machine. Its armor demanded weight, its gun demanded space, its suspension and drivetrain had to carry everything. Its engine was expected to move it, despite having originally powered considerably lighter vehicles. Every improvement added another burden, and every production simplification risked creating another failure. Yet it would be wrong to describe the Tiger too simply as a useless tank. When properly maintained and operated, it could be formidable. Later modifications improved reliability, including changes to seals, gaskets, drivetrain components, tracks, and sprocket wheels, while improved driver training also helped. By March 1945, recorded operational availability for Tiger IIs had improved considerably, although the strategic situation meant that Germany could no longer exploit that improvement effectively. Today, surviving Tiger IIs preserve the physical evidence of that contradiction. One early vehicle, Tiger II V2, survived from the Henschel testing program and is now associated with the Tank Museum at Bovington. It is a remarkable survivor, but it is also a reminder that the tank's history began not on a battlefield, but on proving grounds where engineers were trying to understand what nearly 70 tons of steel could demand from an engine, transmission, and suspension. So why did Hitler delay the Tiger II after it supposedly failed to reverse? The historical record gives a more revealing answer. He did not simply delay it because of one failed reversing demonstration. The evidence points instead to a program caught between technical problems, production pressure, and Hitler's broader insistence on increasingly powerful armored weapons. The Tiger II entered production before its testing had fully resolved its weaknesses, and those weaknesses followed it into combat. Return now to that battlefield outside Caen. The smoke is thinning. The enormous tank sits among the hedgerows, its gun still capable of destroying an enemy vehicle from a distance. From the outside, it looks almost invincible. But inside the machine, thousands of moving parts are carrying a burden that the engineers had struggled to tame. That is the deeper lesson of the Tiger II. It was not defeated simply because it was badly designed, nor was it delayed because one maneuver went wrong. It was the product of a wartime system increasingly trying to solve strategic problems with engineering ambition. Germany needed more tanks, yet built one that consumed enormous resources. It needed reliability, yet pushed production forward before testing was complete. It needed mobility, yet created a machine whose weight made every mechanical failure harder to overcome. The Tiger II could be extraordinarily powerful. It could also be extraordinarily difficult to keep moving. And that may be the most revealing image of all. A tank built to dominate the battlefield, standing silent when its engine, transmission, or final drive could no longer carry its weight. In the end, the Tiger II's story was not simply about how powerful a tank could become. It was about the point at which power itself became a burden.